नमस्कार दोस्तों, स्वागत है आपका मेरे चैनल मैथमेटिक्स पर, विकास मैथमेटिक्स पर। तो आज हम पढ़ेंगे टेलर सीरीज थ्योरम टेलर्स थ्योरम फॉर अ फंक्शन ऑफ टू वेरिएबल्स। ओके, एंड इट इज टेलर्स series for function of two variables. Now watch this series carefully. So fx y, this is a function of two variable fx and y, and is equal to f a b. When we differentiate function or without differentiation, let's say this function is function of x and y, this contained to two variable only. So when we put value of x is equal to a and y, then we get a and b. After putting this value, after that fx, what is mean by fx? This means first derivative with respect to x of this function, and then we put value of this value of a and b. X is equal to a and y is equal to b in that differentiate function. After differentiation, we'll put x is equal to a and y is equal to b, so we get differentiated function a b and multiply by x minus a. Now it is first differentiate with respect to x. Now differentiation with respect to y, and we put again value of a and b, multiply by y minus b. And what is this x minus a? This x minus a is equal to h. In previous video we know that what is a Taylor series? Fx plus h, f dash x plus h square divided by 2 divided by something. This is our this was a Taylor series for single variable function plus 1 by 2. Now double time derivative with respect to x and put value of a and b and x minus a square, plus double time derivative with respect to y, put value of x and y instead of put a and b instead of x and y minus b square, plus 2 x minus a y minus b, and first with respect to y, then with respect to x. First with respect to y, then with respect to x, plus 1 by 3 factorial for third degree term for 3 powers or for up to 3 powers. F triple x means triple time derivative with respect to x, first derivative, second derivative and third derivative with respect to x, then x minus a cube plus triple time derivative with respect to y and y minus b cube. Okay, then 3 first double time derivative with respect to x. First we will differentiate with respect to y and then double time with respect to x. So it is double time with respect to x, and therefore x minus a square and 3y minus b. Similarly for this 3fx double time derivative with respect to y, so y minus b square, and this is after when we put value of a and b instead of x and y, it is and x minus a. So this is our Taylor series for function of two variables. Now I will take an example which is based on it. So the example is that expand tan inverse y over x in powers. This is our problem. Okay, the above is series. The above is series. We will use this series to derive solution. in powers of x minus 1 and y minus 1 up to third degree term, up to third degree term. And hence compute f of 1.1, 0.9 approximately. Okay, now this is our given problem. Okay, so first we will differentiate this function according to this given series. First, this is first time derivative with respect to x, second time derivative with respect to x, and so on. After this, we will put value of x. What is this x and this y? So for this question, the value of x is 1.1 and value of y is 0.9. We will put this x and y value in this given series, then we get approximate value. First we will try what is the series, how we will try series for as per this Taylor series. Now first our is fx, first derivative with respect to x. So derivative of tan inverse, so d over dx of tan inverse y over x. So we know that it is 1 divided by 1 plus this y over x square, and again d over dx of y over x. Okay, now it's a simple calculation, you can drive it easily. So our fx will be minus y over x square plus y square. You can easily drive it by this method. It is a simple differentiation only. You can did it in your 11th 12th class maybe. Now put value of a and b. So value of a is, because this is x minus a is equal to h, so our our a is 1 and b is 1 also, so it is minus 1 divided by 1 plus 1 is minus 1 by 2. So we get our first derivative with respect to x is minus 1 over 2. So first derivative with respect to x is minus 1 over 2. Similarly for y, we get, so f of y x divided by x square plus y square, f of y. Now again we will put value of x is equal to 1 and y is equal to this, so it is 1 over 2. So fx and fy is minus 1 and 1 by 2 respectively. Then so we get fx, fy, and this is our now x minus a square. Now double derivative with respect to x. Now again differentiate this function with respect to x. So f double dash x means double derivative with respect to x. You get 2xy over x square plus y square whole square. So it is 2 divided by 1 plus 1 square. It is 1 divided by 2 also. Okay, now just a minute. I'm zooming this screen. Start after zoom the screen. Fx, fy, f double dash x and fyy means double derivative with respect to y of that function. So it is minus 2xy divided by x square plus y square whole square. Fx, so this is this. So we get again minus 1 over 2. Now another is the y and fxy. First with respect to y, then with respect to x. So fxy. So fxy, we get fxy is 0, and another is f triple time derivative with respect to x. So triple time derivative is minus 1 over 2. Now f triple time derivative with respect to y is 1 over 2. Now this is f triple y, f triple x. Now f double dash xy. F double dash xy. So f double xy. F double xy is again minus 1 over 2. And f x y y 1 over 2. So again I'm cross check this. Fx is minus 1 over 2. Fy is 1 over 2. F double dash is 1 over 2. Fy minus 1 over 2. Fxy 0. F double dash f double x and y is minus 1 over 2. Okay, and fxyy 1 over 2, and this triple and this f triple x sorry, f triple x minus 1 over 2, and triple y is 1 over 2. Okay, now put all these values of differentiated function in this given series and put value of 1.1, 1.1 instead of x and 0.9 instead of y, then we get approx value of this function. Okay, up to third degree for this h and this k. So f of a b, now tan inverse 1 over 1. So tan inverse 1 is 45 degree, means pi by 2, sorry, pi by 4. So for this we get pi by 4 tan inverse 1, because tan inverse 1 is pi by 4. Now x minus a, and a is 1, so x is equal to 1.1, 1.1 minus 1, and derivative of with respect to x, and place x is equal to a and y is equal to b, then we get minus 1 over 2. So fx is minus 1 over 2, so it is minus 1 over 2 plus y minus b. Now value of y, we will put 0.9, 0.9 minus b, sorry, it is x and b is also 1, because x is equal to 1 and y is equal to 1, put this by this equation which is given in our problem. Now fy, first derivative with respect to x, and put x and y, a and b instead of x and y respectively. So fy is 1 over 2 plus 1 by 2 factorial x. X is a is 1 and x is 1.1. Now first replace this 1 by 1. X is 1.1 and a is 1, y is 0.9 and b also 1, and it is 0.9, b is 1, 1.1, a is 1, 0.9 and 1, x is 1.1, 1.1, a is 1, y is 0.9 and b is 1. Again x is 1.1 and a is 1, y is 0.9, b is 1. Okay. Now replace the value of f double dash x a b with this 1 over 2, so it is 1 over 2, 1 over 2 plus 0.9 fxy and fxy. This is fxy is 0, so fxy is 0. Now this is multiplied by 0, so it is whole term will be 0 plus fyy is minus 1 over 2, fyy ab is minus 1 over 2, multiply by minus 1 over 2, so it is minus 1 over 2 plus 1 by 3 factorial, 1.1 minus 1 f triple f 3 time derivative x, so it is minus 1 over 2, so it is minus 1 over 2, multiply by minus 1 over 2 plus f triple derivative with respect to y is 1 by 2, and it is a and b also will present, so I missed it. F triple y is 1 over 2, 1 over 2 Now f x and y, first with respect to y, then double time with respect to x. So this is minus 1 over 2. It is minus 1 over 2. So minus and 1 over 2. 1 over 2 multiplied by this 3, 0. Now 3 f x y y, f x y y, 1 over 2. So this is 3 cross 1 over 2 and so on. ये हमारे पास so we get this this series after put x is equal to 1.1 and 0 y is equal to 0.9 and x a is equal to 1 and b is equal to also 1, and these all derivatives which we will try by differentiation, and you know how to differentiate it. If you don't know, so watch my previous video in our playlist, means in playlist in successive differentiation. So you will found how to differentiate with respect to x, with respect to y, or any function. So this is a differentiation of function, double derivative, triple derivative, maybe anything. So we get this in this series, and in last, when we calculate these whole terms, so we get value .6857. When we calculate these whole terms, we get a value 0.6857. So this is our value of function up to third degree term when we put x is equal to 1.1 and y is equal to 0.9. Guys, so this is our Taylor series. It's very easy. If you know about this series, then you'll get easily any, you can easily find it, value of x or value of y approximately at any value which is as in given in this question. Okay, so guys, if you like my video, please hit the like button and subscribe channel and share another people. Thank you.